What are the challenges in implementing new sensor technologies? In the fast-paced world of electrical engineering, the implementation of new sensor technologies is a hot topic. Recently, engineers have been facing several challenges that are making this process more complicated. As technology evolves, the demand for advanced sensors grows, but so do the hurdles in their application. One of the main difficulties is the requirement for extra electronics. Each sensor often needs additional triggering circuitry, increasing the number of components required. This not only raises costs but also complicates the design and maintenance of the systems involved. Cost is another significant obstacle. New sensor components, particularly those designed for high-performance tasks, can be quite expensive. This includes not only the sensors themselves but also the necessary supporting hardware, such as high-voltage filters. The high costs can limit the applications and environments in which these sensors can be utilized. Selecting the right sensor is not as simple as it seems. Engineers must carefully match the sensor's resolution, accuracy, and environmental rating to the specific application. Choosing an inappropriate sensor can lead to subparing performance or even complete failure in challenging conditions. Integration with existing systems presents its own set of challenges. New sensors need to work seamlessly with current controllers and software. If the feedback signals from the new sensors are incompatible, the entire system may not operate as intended. Signal integrity is also a constant concern for engineers. Sensors that provide real-time feedback are particularly sensitive to electrical noise. To protect the signals, engineers must use shielded cables and ensure proper grounding, which adds to installation complexity and costs. Calibration and alignment are vital for ensuring accurate data collection. Sensors must be set up correctly, as misalignment or poor calibration can lead to errors that impact the overall performance of the system. Latency and update rates are critical in real-time applications. The response time of the sensor must align with the system's needs. If the feedback loop is too slow, it can lead to instability or lag, which diminishes the system's effectiveness. Interference is becoming a more pressing issue, especially in crowded environments such as those involving autonomous vehicles. As more sensors are integrated, the potential for radar and other types of interference increases. This can degrade performance and introduce new engineering challenges. Finally, determining what data is necessary and which sensors can provide that information is essential in smart manufacturing. Engineers must clearly define their objectives before selecting and installing sensors, which often involves upfront planning and trial and error. In summary, implementing new sensor technologies in electrical engineering involves navigating various challenges, including cost, compatibility, performance, and reliability. Each project presents unique technical hurdles, from hardware design to software integration and real-world operation. Addressing these challenges requires careful planning and testing to ensure successful implementation.